Okay, this is actually, I meant to put this at the top here, my bad. We are on Unit 2, Lesson 2. That's what this is. Let me write that. Unit 2, Lesson 2. So we're going to do a couple little slides here, and then we're going to go through some examples of proofs. So to start with, what is a proof? If you're like, wait, what introduction to proofs? You haven't even talked about a proof. So in the math world, you might think that mathematicians just live their lives solving like algebra questions and then just like go, okay, I'm done with that one. Okay, I'm done with that one. A lot of very, very high level, like PhD level math. Almost all of what they do is proofs. They want to create logical mathematical arguments, so things that make sense about math, right? To show that something is true, right? If I'm proving something, I'm trying to show that it is true. Now, at our level, we make these very simple. That's because what we're trying to prove is, again, pretty simple things to understand. At those high levels, they're writing books trying to prove these really complex mathematical things about the universe and how black holes work and stuff like that. Ours are going to be very simple. We use what's called a two-column proof, and this is what it looks like. On one side, you have statements and about just saying this thing is true, but you have to give a reason, right? In the real world, if you say something, you better be able to back it up, right? You can't just say, oh, the sky is pink, the sky is green. People are going to look up and be like, no, it's not, it's blue. Yeah. And you're going to be like, well, okay, I don't have any reason to back it up. So what we do is we put a statement here, and then we put the reason why it is true. So here's just an example of one. This one's a bit complicated. We're going to work our way up to this. But all over here, these are just statements. Angle RST equals 50, and then we have the reason for why we're allowed to say that over here. And we're going to talk about that in just a bit. So again, these are just things that we say. These are the reasons why we're allowed to say them. Now again, how a proof looks is you're going to have some given information. So we can see, given this picture, and that these things are already accepted to be true. And that's why here, for the reason, you can see it's given. We're going to talk about that, like I said, in a bit. And then this is our goal. The goal is to prove this thing right here. Again, if you notice, that's the very last statement. So how it's going to work again, we're going to say a bunch of stuff. Our very last statement is going to be what we're trying to prove, that it is a true thing. So now I do want you to copy this next slide. It is going to be a little bit of writing. So here's some common reasonings that we're going to come across, because again, there's only so many we use because we keep this pretty simple. And like I said, reasonings is what is in the second column. We have statements. The statements will all be given to you in this class to make it easier. You have to come up with the reasons. So here's common reasons you can use. Given. Again, I talked to you guys about this yesterday. I recommend don't pause the video until I move on. As I start talking, copy. If you need to pause because I'm ready to move on, then do it then. But if you pause immediately once you need to copy something, then you just have to sit while I keep talking about it, yeah? So try and copy this as I'm talking. And then if you need more time before I move on, then hit pause. So given is a very common reason. We use this when we have information given to us to start with. So if I said angle 4 is 30, and then you would go, why? Your reasoning is, well, it's given to us, that it was already told to us that it was 30. And they go, oh, okay, yeah, it's already given to us. Vocabulary words are also very common reasons because vocabulary words have definitions. So sometimes if I were to say, for example, these two angles are equal, and somebody would go, why, right? Why are these two angles equal? And then I might say, well, it's the definition of vertical angles. Vertical angles is a vocabulary word, and part of the definition of them is that they're equal. So again, if I want to state these two things are equal or these two things add to 180, the reason might be that it's the definition of what these two angles are. This is another one, subtraction, addition, multiplication, or division property. So they might use any one of those. They might say subtraction property, or addition property, or multiplication property, or division property. These are used to show what we are doing to solve an equation in the proof. So if I have to solve, sometimes we do have to solve an equation in our proofs. And if we do, we have to say what we're doing. So if I go from step 1 to step 2, and what I did was subtract something, that's my reason. This is a true statement because to get here, all I did was subtract. Yeah. So sometimes we might use this as well if we're trying to solve an equation in our proof. Okay, this is a new term probably for you guys, transitive property. You may have learned this in Algebra 1, I'm not too sure. But what transitive property states, we would use it when this following situation occurs. If A equals B, so say A, B, and C are all numbers or angles or something like that. If A equals B and B equals C, then A equals C. What this means is if both A and C, if they both equal B, well then they have to equal each other. They both equal B, so they have to be the same. So this will sometimes occur when we're talking about angles. If this angle equals that angle and that angle also happens to equal another, well then my two angles on the end have to be equal as well. Lastly, we will also be doing substitution property, and we just use this whenever we're plugging into a variable. So if I show a statement and all I did was plug something in, my reason is substitution property. So at this point, if you need to pause to finish copying, then you can pause and finish copying and then move on. But what we're going to do from here actually is go through some example problems, some example proofs. Make this full screen. Okay. Oh, one more thing I need to fix. Sorry, I'm taking some time here. Oops, nope, I gotta do that for a second. That's okay. Okay, so let's look at a proof. So this is one example. Let me go back real quick. Nope, we're good. So here's what we have. This is how all proofs will happen in this class. We have a picture that we're gonna reference. We have some given information, and this is our end goal. Once again, how these are gonna work. Again, pause if you need to copy this down before I move on, actually. All of the statements are gonna be given to us. We just have to fill in the reasons for why those statements are true. So again, based off this picture and the fact that what this says is R is parallel to S. That's what this little symbol means. R and S are parallel. So if you notice, our first statement is the given. We always start with the given information because that's what we have to work with, right? When you copy this, guys, you don't need to copy the blue stuff. If you'd like, you can just copy the reason itself. So now we have to go from here. So here's my next statement. I'm going to have to give a reason for why this statement is true. And again, the whole purpose of this is, in the end, I want to prove that angle 2 is equal to angle 8. That's my goal. So let's look at angle 2 and angle 6. Here's angle 2 and here's angle 6. What I have said is that those angles are equal, and now I need to give a reason. So if we look at 2 and 6, we should notice they have a special relationship. Within each x, they are in the same position, right? 2 is in the top right corner of this x, and 6 is in the top right corner of this x. So if you recall, these angles are called corresponding, and corresponding angles are equal. So that's why my next reason is corresponding angles. You can go ahead and leave off the postulate, that's fine. You can just say corresponding angles. So I said angle 2 equals angle 6. My reason is, well, that's because they're corresponding angles and they're congruent, they're equal. So that's why I'm allowed to say that. So now my next statement is angle 6 is congruent to, that's what this little symbol means here. Again, same thing as equal. 8. So let's look at angle 6 and angle 8. So here's angle 6 and here's angle 8. So you want to ask yourself, why is that true? Why are those two angles equal? Well, the reason why is because of their relationship. 6 and 8 are what? 6 and 8 are vertical angles, and so vertical angles are congruent. So that's my next reason. I am allowed to say that angle 6 equals angle 8 because they are vertical angles and vertical angles are the same. So now we're at our last step. This was our end goal, right? Our end goal was to say angle 2 is congruent to, is equal to angle 8. So what you do at this point, you want to look up at your statements and see what information we have to say this is now true. Now, if we notice, here's what we have. We have 2 is congruent to angle 6, as well as that 6 is congruent to angle 8. Therefore, because both of these angles equal angle 6, they have to equal each other. This is a property you just wrote down. This is the, let's see if you can recall it, transitive property. If 2 and 8 both equal angle 6, then 2 has to equal 8 as well. So there is one example of a proof. We're going to do 1 or 2 more here. So go ahead and once more copy down the picture. And let's look at our givens and our proofs. I'm going to walk you through this one, and then I'm going to have you try one more. So given D is parallel to E. So here's my parallel lines. As well as that the measure of angle 1 is 132. So here's angle 1. It's 132. So I'm going to real quick minimize this and pull up a smartboard screen so I can write over it. So here's angle 1, sorry. Angle 1, come on, is 132 degrees. If you're ever given numbers as information, you always want to label them on your picture. So make sure you have that picture copied down, and let's go from here. So here's all my statements. I need to give my reasons. Now again, my first reason is always given, guaranteed, 100%, you can assume this. Our first reasons are always going to be the givens because that's what we're working with, right? So we listed 2 things here. We listed both that D was parallel to E and that the angle 1 is 132 because that is given information. It's given to us. Here's our end goal, that angle 8 equals 132. So notice that's our last statement because that's always our last statement. Given is our first statements, prove is our last statement. So let's see what our reason is here. Our next statement is measure of angle 1 equals measure of angle 8. So I'm going to give you a second, I'm going to help you through it, but you're going to give me the reason. Here's angle 8. They are saying those 2 angles are equal. Why are they allowed to say that? What is the name of the relationship between these 2 angles? Remember, inside or outside the river, interior, exterior, and then alternate or consecutive, same side of the bridge or opposite side of the bridge. What's the name of the relationship between these 2 angles? Okay, these angles are, oops, let me go ahead and release this. These 2 angles are alternate exterior. So what you can say is they're equal because they're alternate exterior angles, and from your notes, alternate exterior angles are equal. So since we said that angle 1 equals 132 and angle 1 has to equal angle 8, well, now we can say that angle 8 equals 132. Now we can say 2 different things here actually. We can either say the transitive property or substitution, because I could take this 132 and substitute it into angle 1, and then I'd have my last statement. Here we said transitive property. Since angle 1 equals 132 and angle 1 equals 8, 8 also has to equal 132. Okay, I want you to go ahead and try this one. Do the whole thing. You've got 1, 2, 3 reasons to give. You might struggle a little bit with this last reason. That's okay. If you can at least get the reasons 2 and reasons 3, then you can do that. We'll come back and we'll check. Okay, so here's all of our statements. We already have the given listed, that A is parallel to B and 7 is 40. we are trying to prove that angle 4 is 140 degrees. So let's see what we got here. The next statement they said was that angle 4 and angle 7 equals 180. Our reason comes from what the name of their relationship is. So here's angle 4 and here's angle 7. You should have said that the name of the relationship between those two is consecutive interior. And from your notes, this is a true statement because consecutive interior angles add to 180. Then we go to the next step. We have angle 4 plus 40 equals 180. Now this is a little tricky. How did we get from statement 2 to statement 3? That's our reasoning. How did we get from 2 to 3? Notice what changed. 2 said a measure of angle 4 plus measure of angle 7, and now this says measure of angle 4 plus 40. But hey, we knew that angle 7 was 40, so all we did was plugged in 40 into the measure of angle 7. You should have put, if this is plugging in, this is substitution for 3. I substituted 40 into 7. That's my reason I was able to do that. Now let's talk 3 to 4. Again, whenever you're trying to figure out the reasons, you need to think, how did I get from this step to the next step? What's my reason? So how did we get from 3 to 4? Well, if we notice what changed, this 40 is gone, right? And now we have 140 on this side. So if you notice, all we did to get from step 3 to step 4 is we subtracted 40 over to the other side, and that would give us 140. So our reasoning is exactly that. We subtracted. So subtraction property is our reasoning. So these were some more basic proofs. We're going to do some more difficult ones in class to hopefully give us a bit more of a stronger base with them.